Hello everyone. In this class, we will learn about transactions. A transaction is a mechanism that consists of a series of SQL statements that together form a logical unit of work. The entire logical unit appears as a single entity, where either all the statements in the unit are successfully executed, or the system returns to the state before the transaction started. This ensures the synchronization of operations within the transaction and maintains data integrity. For example, in banking transactions, the transfer of funds requires both the deduction of funds from account A and the increase of funds in account B to either both happen or not happen at all. To address similar problems, database systems introduce the concept of transactions. Transactions must satisfy 4 fundamental properties: atomicity A, consistency C, isolation I, and durability D. 1. Atomicity. It means that a transaction must be executed as a whole, either executing all the operations on the data or none at all. 2. Consistency. It means that when a transaction is completed, all the data must be in a consistent state. 3. Isolation. Isolation, also known as independence, means that the modifications made by concurrent transactions must be independent of each other. The data processed by one transaction should either be in its original state before other transactions are executed. The state after other transactions have been executed, however, it should not be affected by other transactions that are currently being processed. 4. Durability. Durability refers to the property that once a transaction is completed, its effects are permanently stored in the system. In other words, the operations of a transaction are written into the database. This mechanism of transactions ensures that a transaction either successfully executes after being committed, or is rolled back if it fails. Therefore, transactions provide recoverability for data modifications, which means that when a transaction fails, the modifications made by that transaction are rolled back to the state before the transaction was executed. In contrast, using regular batch processing may result in some statements being executed while others are not, potentially causing data inconsistencies. Next, let's learn about transaction handling statements. If you want to treat a set of SQL statements as a transaction, you need to explicitly start a transaction by executing the following statement. Start transaction declares the starting point of a transaction, representing the beginning of a logical unit. If any errors occur within the transaction, the entire transaction will be rolled back to the starting point declared by the start transaction statement. The second statement is commit. Commit ends the user-defined transaction, making the modifications to the database data that occurred since the start of the transaction permanent, and then releases the resources occupied by the transaction connection. To give an example, let's define a transaction that adds 10 points to the scores of all students who have taken the C3 course and then submit the transaction. The specific statement and execution result are shown on the screen. Start transaction. Start a transaction. Update SC set grade equals grade plus 10, where NO equals C3. Modify the SC table to add 10 points to the scores of students who have taken the C3 course. Commit. Commit the transaction. The third is the rollback statement. It rolls back to the starting point of an explicit transaction or an implicit transaction, or to a specific save point within the transaction. The fourth is the save point statement. Rolling back a transaction can incur significant system resource overhead if it is anticipated that there will be very few errors during the execution of a transaction. The save point mechanism can be used. It provides the ability to roll back part of a transaction, so that when executing a rollback statement, it is not necessary to roll back to the beginning of the transaction. Translation: multiple save points can be created within a transaction and after the transaction is committed. The save points within the transaction are deleted. Additionally, when rolling back to a specific save point, any save points created after that save point will also disappear. The statement to define a save point is save point underline name. The statement to use a save point is rollback to save point underline name. The statement to delete a save point is release save point underline name. Let's give an example by defining a transaction that adds a record to the student table, deletes that record, rolls back to the save point, and finally commits the transaction. The operation statements are displayed on the screen. Start transaction. Start a transaction. Insert a record into the student table. Save point S1. Create a save point called S1. Delete from student where snow equals 0703002. Delete the student record with the student number 0703002 from the student table. Roll back to save point S1. Roll back to the save point S1. Commit. Commit the transaction. The final execution results, as displayed on the screen, show that when executing the select statement to view the student table, it is observed that the student record with the student number 0703002 has not been deleted. The insert operation before save point S1 was executed, while the delete operation after save point S1 was rolled back and undone. Multiple choice questions. Select one answer choice. First, the operation that implicitly commits a transaction is C. A. Select. B. Update. C. Create table. D. Delete. Second, the characteristic of a transaction that requires it to be unaffected by other transactions is C. A. Atomicity. B. Consistency. C. Isolation. D. Durability. Third, the characteristic of a transaction that requires it to be treated as an indivisible unit of work is A. Atomicity. B. Consistency. C. Isolation. D. Durability. Fill in the blanks questions. First, consistency in MySQL is primarily achieved through the log mechanism. Second, after setting a transaction save point, the command to roll back to a specific save point is rollback to save point underline name. Third, in MySQL, the command to set a transaction save point is save point underline name. Fourth, in MySQL, the InnoDB storage engine supports transactions. Multiple choice questions select more than one answer choices. First, to start a transaction, you can use A. Begin. B. Start transaction. C. Commit. D. Rollback. 2. Correct statements about transactions in MySQL are ABC. A. A transaction is a set of operations on the database. B. All statements within a transaction are either executed or none of them are executed. C. The operations within a transaction take effect only after a successful commit. D. Start transaction can be used to commit a transaction. True or false questions. First, a transaction is a set of operations on a database and consists of one or more SQL statements. Answer: false. Second, the execution of a transaction either succeeds or returns to the state before the transaction started. Answer: True. Third, multiple save points can be created within a transaction. Answer: false. Fourth, by default, each SQL statement executed by a MySQL user is treated as a separate transaction and is automatically committed. Answer: true. Fifth, after executing commit to commit a transaction, rollback is used to undo changes if needed. Answer: false. Sixth, MySQL transactions do not allow nesting. Answer: true. Seventh, when rolling back a transaction, all operations within the transaction are undone. Answer: true. Eighth, after rolling back to a save point, any save points created after that save point will be removed. Answer: true. Short answer questions. 1. Please use a transaction to complete a money transfer between two accounts. The table name is sh_user, and the main fields are name and money. The table contains data for Alex and Bill, both having 1,000 units of currency. Answer: start transaction. Update sh_user set money equals money minus 100 where name equals Alex. Update sh_user set money equals money plus 100 where name equals Bill. Commit. 2. Please provide a brief description of the A, C, I, D characteristics of a transaction. Answer: atomicity. A transaction is treated as an indivisible unit of work. C. Consistency. The database remains in a consistent state before and after the transaction. It guarantees that the database system never returns to an unprocessed transaction. I. Isolation. Transactions are executed in isolation from each other. D. Durability. Once a transaction is committed, its changes are permanent. We have introduced the concepts and basic operation statements related to transactions up to this point. We hope that everyone has a good understanding and mastery of them. Thank you all.